In this video, we will be discussing a few questions from the chapter of straight lines, and these questions I've taken them from the Maharashtra government textbook 11th standard maths part 1 chapter 5 exercise 5.2. These questions are all based on the general equations of straight lines, and in case if you feel that you're not very clear with the theory, then do check out the video in which I have discussed only and only the theory that you require for solving the sums of this chapter. You can find the link in the description box below. Let's begin with the questions. The first question tells you to find the slope of each of the following lines which passes through the given points. I'll solve it for the first A part. For B, C and D, you can find the slope by yourself with the help of the same very method that I'm discussing for part A. So let's treat point A as x1, y1 and point B as x2, y2. The formula for slope is very clear. The formula is y2 minus y1 upon x2 minus x1. Because I am treating my point B as x2, y2, the value of x2 will be 4 and the value of y2 will be 3. I am treating my point A as point x1, y1. So x1 will be 2 and y1 will be minus 1. So let's put in the values of y2 minus y1. So that will be 3 minus 1 divided by x2 minus x1 is going to be 4 minus 2. Even if you want to reverse the order, like you want to treat B as x1, y1 and A as x2, y2, then also it is absolutely fine. Your answer will still remain the same. You can check it out by yourself. So the slope is going to be 3 minus 1, that is 4, divided by 4 minus 2, which is 2. So the slope of line AB for that first A part is going to be equal to 2. You can use this very formula and calculate the slope for option B, C and D as well. We will go ahead with question number 2. And in question number 2, they are saying that if the x and y intercepts of a line L are 2 and 3 respectively, then find the slope of line L. X intercept and y intercept means that point where the line is going to intersect with the x and y axis. So the line is currently looking something like this. It is intersecting this x axis at 2, 0 because they have said that the x intercept is 2. And the point where it is intersecting the y axis, it is the number 3 on y axis, and that is why that point will be 0, 3. And you need the slope of this line. The formula for slope was y2 minus y1 upon x2 minus x1. And let's say I am treating this point as x1, y1. And let's say we are treating this point as x2, y2. So the value for y2 is 3. So we have 3 minus, so y2 minus y1, right? So y2 was 3 minus y1 is going to be 0. Divided by x2, x2 will be 0 minus x1. So x1 will be the x coordinate of this point, that is 2. So y2 minus y1 upon x2 minus x1, that turns out to be minus 3 upon 2, which is the slope of the required line for question number 2. Similarly, let's go ahead with question number 3. Find the slope of line whose inclination is 30 degrees. Inclination means the angle made by the line with the positive direction of x-axis. And if that is 30 degrees, the value of slope m will be given by tan 30, which is equal to 1 by root 3. In a similar way, you can answer the fourth question. Find the slope of a line whose inclination is pi by 4. So the slope this time will be tan pi by 4. The shortcut was pi will be 180 degrees. Pi radians will be 180 degrees. So if pi will be 180 by 4, that is pi by 4, that will be 45. And tan 45 will be equal to 1. So the slope of line for the fourth question will be equal to 1. And the fifth question says a line makes intercepts 3 and 3 on the coordinate axis. Find the inclination of the line. The diagram for the fifth question remains very much the same like this diagram. Just that in this diagram I had said that the intercepts were 0 and 3, right? In this fifth question they are saying that the intercepts are 3 and 3. So on the x-axis the line is passing through 3, 0. And on the y-axis we can say that it is passing through 0, 3. Now this is one thing you need to understand, that if a line is making equal intercepts on the coordinate axis, then the slope of it will be minus 1. Why does that happen? You can check it out by yourself. The slope for this kind of a line, check that the x-intercept and the y-intercept is equal. So the slope will be, you can say this point is like x1, y1. Consider this point as x2, y2. So when we say y2 minus y1 upon x2 minus x1, y2 is 3. So we have 3 minus y1 will be 0 upon x2, that will be 0 minus x1, that will be 3. Okay, So the slope turns out to be -1. Now, even if it was not 3, even if it was some random number like k, but like I said, if the line is making equal intercepts on the coordinate axis, this will be k0 and this will be 0 comma k. In that case, the slope will become m equal to, again, y2 minus y1, that would become k minus 0, divided by x2 minus x1 would be 0 minus k, and that would give you -1. So the slope of any line that is making equal intercepts on the coordinate axis, the slope of that kind of a line will be equal to -1. Okay, and it's very clear that this angle which you see here will be 135 degrees, and this angle out here will be 45 degrees. Okay, that's a little bit of extra information on straight lines. The fifth sum, like I said, remember it as a result that if a line makes equal intercepts on coordinate axis, the slope of that line will be -1. Let's go ahead with question number 6. You don't have to use the Pythagoras theorem, and without using that Pythagoras theorem, you need to show that A, B and C are the vertices of a right angle triangle. Let's try to find the slope of AB. So the slope of AB will be y2 minus y1 upon x2 minus x1. Treat point B as x2 y2 and point A as x1 y1. So we have y2 minus y1 upon x2 minus x1. The slope of AB turns out to be 1 upon -1, that is -1. Similarly, let's try to find the slope of AC. So x2 y2, x1 y1. The slope will be y2 minus y1 upon x2 minus x1. This turns out to be -5 upon -5, which is equal to 1. And yeah, you can see that slope of AB into slope of AC is equal to -1. That means that AB is perpendicular to AC. So the triangle is looking something like this. This is AB and this is AC, giving you a right angled vertex at point A. So without using the Pythagoras theorem, by simply using this result, that slope of two perpendicular lines, the product of it will be equal to -1. By using that result, we are showing that AC and AB are perpendicular, which means that the 3 points are the vertices of a right angle triangle. Okay, let's go ahead with question number 7. It says that find the slope of the line which makes an angle of 45 degrees with the positive direction of y-axis measured anti-clockwise. So if these are your coordinate axis, the y-axis is the one which is going vertically upward like this. This was your x-axis. The line makes 45 degrees angle with the positive direction of y. Positive direction of y means the one that is going up, and 45 degrees has to be measured in the anti-clockwise direction. So when you measure 45 degrees in the anti-clockwise direction, you will realize that the line looks like this. Now this line with the positive direction of x-axis, it is making a total angle of 135 degrees. How is it 135? This much was 90, and to that 90 you are adding an additional of 45 here. So that made it a total of 135 degrees with positive direction of x-axis, and that is why the slope will be tan of 135, which will be equal to minus 1. Cos 135 and sin 135 will be -1 by root 2. Okay, cos 135 -1 by root 2, sin 135 1 by root 2, and tan 135 will be -1. So in short, the slope of this line is going to be equal to -1. Okay, with that, let's go ahead with our 8th question. Find the value of k for which these points are collinear. Now, because the points are collinear, the slope of PQ and the slope of QR is going to be the same. So we will start with slope of PQ equal to slope of QR. Slope of PQ will be y2 minus y1, that is 1 minus -1, divided by x2 minus x1, which is 2 minus k. That should be equal to the slope of QR, which is 5 minus 1, divided by 4 minus 2. Okay, 5 minus 1 will be equal to 4. This will be 2. 4 upon 2 is giving you a 2 on the right hand side. Take that 2 minus k on the right hand side. So this vanishes from here. 1 minus -1 was giving you a 2 here. You can cancel off this 2 and 2 with each other and say that 2 minus k will be equal to 1. Take that k on the left, take this 1 on the right. So you will have k is equals to 2 minus 1, which is equal to 1. So the value of k for question number 8 is equal to 1. Going ahead with the next question. In the ninth question, we are told to find the acute angle between the x-axis and the line joining the points A and B. So we can simply say that the slope of the line AB, that will be given by y2 minus y1 upon x2 minus x1. So we can treat point B as x2 y2 and treat point A as x1 y1. So y2 is minus 2 minus y1 will be minus 1 divided by x2 minus x1, that will be 4 minus 3. So in the numerator we have minus 2 minus of minus 1, that is minus 2 plus 1, which is minus 1. In the denominator it is equal to 1. So we have MAB as minus 1. If the slope of AB is minus 1, then we can say that tan theta will be minus 1, where theta is the angle made by the line with the positive direction of x-axis. So if tan theta is minus 1, theta will be 135 degrees, which tells us that the line is going to look like this. Okay, something like this, not necessarily passing through the origin. Okay, the points are also given, so the line will be a specific line. I am not drawing the line accurately, but speaking of only the direction, the line will look something like this. What I mean to say is, with the positive direction of x-axis, which was this, the line is making an angle of 135 degrees and this angle will be 45 degrees. In the question they are asking us the acute angle between the x-axis and the line joining the 2 points A and B. So the required acute angle will be 45 degrees. And yeah, that's how we are answering our ninth question. Going ahead with the 10th question, they are telling us that a line is passing through the points A, which is x1 y1, and B, which is h comma k. If the slope of line is m, then show that k minus y1 would be m into h minus x1. So all you need to do is you need to say that the slope of the line will be given by y2 minus y1 upon x2 minus x1. You can treat the point B as x2 y2 and the point A is already x1 y1. So the slope of the line joining A and B, that will be given by y2 minus y1, that is basically k minus y1, divided by x2 minus x1, that is h minus x1. You can take that h minus x1 on the left and that will give you m into h minus x1, and that should be equal to k minus y1. And this is what precisely they had told us to prove in the 10th question. And yeah, that's how we are answering our 10th question. Let's go ahead with one last question in this video. That's question number 11. It says that if the points A, B and C, the coordinates of which are given to us, they are lying on a line, then show that A upon H plus B upon K will be equal to 1. If 3 points are going to lie on the same line, then we can say that slope of AB will be equal to slope of BC. You can also say that will be equal to slope of AC. It's up to you which 2 points you want to consider. So we will start with slope of AB equal to, okay, let's say slope of AC. So slope of AB, we can write it as y2 minus y1, that is k minus 0, divided by x2 minus x1, that is 0 minus h. That should be equal to slope of AC. So y2 minus y1, which is b minus 0, divided by x2 minus x1, that is a minus h. So in the numerator, b minus 0 will simply be equal to b. This will be k, and in the denominator it will be minus h. So you can write that left hand side as minus of k upon h. Well, if you want, you can cross multiply, and that cross multiplication is going to give you, cross multiply in the sense, take this denominator on the left here and this term on the right here. So you have minus AK plus KH equal to, you have BH. Now if you realize you want H and K in the denominator and you want the right hand side to be equal to 1, we will bring that 1 a little while later, but for the time being, just because we want H and K in the denominator, we will divide both the left and right hand sides with HK. So on the left as well as right, we are dividing both the sides with HK. So on the right hand side, H gets cancelled and we have B upon K as our right hand side. On the left, we will separate out the two terms. So we will have HK in the denominator here and HK in the denominator here. KH and HK get cancelled, leaving you with a 1 here. This K gets cancelled with the K here, and you have minus A upon H, which can easily be taken on the right hand side. And on the right hand side, it can be written as plus A upon H. this 1 stays on the left the way it is. So finally we have proved that a upon h plus b upon k will be equal to 1, just like the question had told us to do. This is where I am done with discussing all the sums that I wanted to discuss in this video. I hope that the contents of this video have been somewhere helpful to you in your preparations. Do check out the next video where I have solved exercise 5.3. Thank you for watching.